Hey, welcome everyone. Thank you for joining my talk. We will go over some of the lessons which I've learned building CI/CD pipeline, working for Capital One. So the topic here is, as it clearly says, we are looking for a speed and stability on CI/CD pipeline. And if you are a developer, ever wondered why it takes so much time on CI/CD to get a PR merged, or why it takes so much time to run a unit test on a Jenkins pipeline or such things? I think you are in the right presentation. I'll be covering some of the lessons which I've learned in last 2 years. Quick background about myself. I'm currently leading CI/CD team in Capital One. I've been working with Capital One from last 4 years. Last time I presented in DevCommunity, it was Android Summit. So I was an Android platform engineer back then, but I've been looking into iOS platform development team from last 2 years. So if I'm not presenting in Android Summit or any conference, you might catch me up on YouTube. So I usually post travel videos or cooking videos whenever I get time. Other than that, I'm passionate about hiking mountains. So if I'm not in any professional summits, you might see me on any mountain summit hiking national parks across United States. This is a bit about myself. So before I get into details of the speed and how we can improve stability on the CI/CD pipeline, it's good to understand the CI/CD concepts itself. And this architecture diagram explains what happens in a continuous integration or continuous development environment. So as a developer, we'll be raising a pull request to a repository, and after the pull request is raised, there are certain checks which runs on the code changes which was made, and it goes through a merge process. And then there is a continuous development system where we build different types of applications, like debug applications to be run on simulators, or release builds to be run on the actual iPhone devices for UAT testing purposes. And there is a different stage for releasing to production, like for the test flight, and also for the app store, which is another stage of the continuous development pipeline. So the importance of CI/CD plays a huge factor in making sure the developer productivity is accounted in terms of, like I explained, from the time pull request is raised till the time it is merged. If it takes more time, it basically impacts the developer productivity. And it's not that there is only one commit on a pull request. There are feedbacks which comes in, and there will be multiple commits which happens on the same pull request multiple times. So if the CI check takes more time to complete, that means the productivity of the developer is being impacted. And another importance of CI/CD is that it helps to catch defects early in cycle, because there are multiple checks which runs on each commit. Let's say for a pull request, there is unit test, there is UI test, and we do Swift limit. And there are different combinations of tests which can be run. And also it helps to deliver features to our customers in a timely manner if the CI/CD setup is done in a proper way. And it includes so many factors when we are building a continuous integration or development pipeline. If it is a small size project or if it's a large project, and how many tests are there, so many factors which comes into picture. So as a pipeline responsibility, which I was explaining, if it is a large project consisting of around like 150 developers, and there are 300 pull requests being raised on like every 2 weeks, because that's what happens when you are working for a large project. It's very important to make sure developers are not waiting for their pull request to be merged. Instead, it should be designed in such a way that everything is automated and running, and feedback is given straight away. And after the code review and approval is done, it's getting merged to the repositories without any delays. So if the CI/CD system is not designed properly, right? So developers will usually get into this mode where like they don't know what's happening with their pull requests. They think that the commit which they are pushed is everything is good, but they don't know what is happening in the background or why the checks are failing. If the checks are not designed properly, or the CI/CD pipeline is not designed properly, like we live in a world, there are so many distractions. Like myself, sometimes when I open a pull request, you don't know what is happening in the background. You usually open a Twitter, or you open Slack, or for some conversations, or there are different modes where developers might get distracted. This is just one funny clip which I got. Like, if it takes more than 3 to 4 hours for a CI check to complete on a particular commit, developers might end up thinking they might go and watch Godfather series, or they can travel from, let's say, if you're in Virginia, you can travel from Virginia to New York in 4 hours, right? So we need to be checking and making sure the pipeline what we design is accounting even the extra minute it is going to take running any test or running any checks. So for now, I'll be making some assumptions for a large project so that we can walk through how we can design a CI/CD system. Some of the designs are cross-platform. It does not have to be iOS specific, but we'll get into a section where we'll cover more on the iOS side. So this is an assumption which I'm making for a Git project, which is of like 10 GB size, because it's a large project and there are like 150 developers. And the frequency of PR per week is like 150 pull requests, and the app says this is for the iOS application. It's around like 190 MB, and the release frequency which is getting released to App Store is 3 weeks. And the number of unit tests and UI tests a project can have can vary from 1,000 to 10,000. Usually the number of unit tests is more. And I've considered for assumptions like there are 10,000 unit tests, and all this test has to pass before merging a pull request with 100% pass rate and so code coverage. For now, I've assumed 80% code coverage. And when run in serial mode, it's going to take like 30 minutes. And the UI test, there are like 1,000 UI tests, which is like integration test or end-to-end test, but not necessary. We have to run all this UI tests for a pull request to get merged. We can consider a critical subset of UI tests to be run for a CI check. And again, 100% pass rate. The test execution time is considered around 15 minutes. And these are the build times, because for iOS, there are multiple build flavors: debug, Preflight, and also App Store. I have not included ad hoc here, but App Store and ad hoc is going to take like around same build times. So this data plays very important role in how we design the CI/CD system, because if you are a small project and if you have small number of tests, the execution time is going to come down eventually, right? So the tools assumption which I'm going to make now was we'll be considering Jenkins as automation server, where the automation checks will be running. And if you have not heard of Fastlane, this is an open source mobile build tools, which can be used for Android and also iOS to build applications to run unit tests or to push to production. And Xcode build is a command line tool which is provided by Apple itself. So whatever you do on Xcode IDE to build applications or to run test, the same thing can be done using Xcode build also. And sometimes you see more benefits running from command build like Xcode build instead of using Xcode IDE, because there is no indexing or Xcode processor which is running Xcode. I've seen like at least 5 to 10 minutes faster when we build in the command line. So this is the assumption which I'm making for the CI/CD project, which we are going to, like pipeline, which we are going to design later in the slides. So I was explaining there are multiple checks which runs on a pull request or a commit which is being pushed to a pull request. So this is just high level category. It can vary depending on projects, but these are the minimum requirements I can see which needs to be added for an iOS project. Is like we should be running unit test, and depending on the project structure, you can have multiple schemes and multiple targets, and the code coverage enforcement will be running security scans and whether the PR is in proper format and lint checks. And there are many varieties of lint checks which can also run Swift lint, and also there is spot spec lint. And critical UI test is what I showed in the previous slide. We are currently assuming there are only 15 critical UI tests which needs to be run, because running 1,000 UI tests is obviously going to take more amount of time. If 15 critical tests is going to take 15 minutes, obviously 1,000 is going to take like 10 plus hours to complete. So it's not ideally suggested to run all those in the PR checks. So from the time pull request is raised till the time pull request is ready to be merged, apart from this checks, we also need to make sure there is code owner approval based on the project requirement. Minimum 1 code owner or 2 code owners are from the Git code owner configuration, how many approvals is required based on the file which was changed. So this is just 10,000 foot overview of an iOS pipeline, how it will look for large projects, especially as you can see from the time pull request is raised till the time it is auto merged to the main branch. And there is a post merge build, just because the release build, what I showed before, it takes like 180 minutes to generate a Preflight or App Store build. And if you have to capture the size of the application after a pull request is merged, it is not recommended to run pre-merge when a pull request is raised, but it is better to run it after it got merged. So that's one of the reason it is moved into a post merge section. And there are different stages of pipeline from the time a commit is pushed till the time a PR is merged and to the time it is released to a production. I've categorized that into 3 different subcategories. The first one is Jenkins pull request build trigger. So it basically includes the source code management and how the builds are getting triggered. And the second category is the PR qualifier. That means what checks needs to be run and how it can be run, and what are the different options developers have to make sure if they need to re-trigger check on a commit. And the third category is the exit test and the app size, which is the post merge section. So what happens after the pull request is merged, and what are the different types of running test on the CA pipeline. So the first thing first, the source code management, which is from the first category. Like we made an assumption that the repo size is around like 10 to 20 GB. So when we are cloning a repository on Mac Stadium machines or any virtual machine, where actually the Jenkins runs and the CHX are being performed, if you're going to clone the entire repository, it's going to take around 15 to 20 minutes just to download the repository, right? So the recommended approach here is, instead of doing the entire clone, we will do a shallow clone. What does shallow clone means? It will basically clone the last commit on the branch which we are referring to. So with this shallow clone depth set to 1, the size of the repo being cloned reduced by like 10 GB to around like 1.5 GB. That means the data which is being transferred and the amount of time it takes to clone the repository, as you can see a great performance improvement over there. And apart from that, when a pull request is raised or a commit is pushed, it is recommended, and I have also seen a great performance improvement just to clone the branch where the test is being run instead of fetching all the remote objects. So, and you can see these configurations on the screenshot, how we can set this in the Jenkins config. This is from the Jenkins UI. We can also do this from the command line also. And there is a link added in this slide, which will basically explain what are the different recommended approach from Jenkins if we are handling a large projects. Apart from shallow clone and the narrow ref spec, there is something also called reference repository. I have not mentioned it here because it's very complex. When we have to do reference repository, it takes the infrastructure to be configured in such a way that there is already a clone version of the code in the master of the Jenkins, so that it can be referred whenever we want to run a checks on as a CI. You can always take a look at the link and for more details. Apart from that, the PR qualifiers category, which I mentioned, covers how the checks are being run on Jenkins. Usually when pull request is raised, you can see a Jenkins running, which will clone the repository and it will run all the CI checks. But depending on the size of the project and how much time it takes to run, let's say unit test and UA test, all this combined together, I would say, like, instead of running everything serially on one Jenkins build, you can have a shell script which will basically make an API call to Jenkins and determine how many number of executors are currently free or how many number of virtual machines are currently free. And based on that, you can divide that executions into multiple parallel builds. So for instance, if you have a project with multiple schemes and The serial build can be run only if the number of virtual node is very less, because we need to make sure it's able to accompany like all the commits which are being raised by all 150 developers, because you don't have control on how many commits can be pushed or how many pull requests can be raised at a given point of time. So that's where the Jenkins API will help us to decide whether to run in a serial mode or in a parallel mode. So for the parallel mode, you can divide it based on the dependency. Let's say scheme 1 is independent of scheme 2 in this block diagram. And scheme 1 has a certain unit test which needs to be run, followed by a UI test, which can go into the first build. Whereas scheme 2, which is entirely independent of the scheme 1 configurations. So it can be built in the second Jenkins build. And by this, you can see obviously like the performance improvement compared to how it is run in the serial mode. And this can also help in terms of like when the commit traffic is high, depending on the project. Usually you see the number of commits being pushed is high between 10 a.m. to 11 a.m. or between like 2 p.m. to 3 p.m. You see the most of the builds running in the serial mode. But if it falls in some other time, the developer will be able to get the feedback on the pull request quickly when it is run in the parallel mode. And from what I've seen from the project which I'm working on, we have seen like 70% performance improvement when the runs are in parallel mode. Apart from that, it's not always necessary that all commits or all pull requests has to go through all these checks of like running unit test and linting or the UI test. Depending on the files change and the project structure, it is recommended like when code only changes, let's say UI test, or it is making only changes to the test framework. So in that cases, we don't really need to run unit tests. It depends on how the project is structured. It's better to check with the architecture team if there is any impact if you just run the UI test for this particular pull request. So in that case, we can easily skip all these different unnecessary checks. And the UI test, since we just have to run like build the scheme for the UI test schemes and just download the application from the artifactory instead of building the application altogether, because what we've seen in the system requirement slide is building the application itself takes 25 minutes. So we can easily save this time if the already built debug application is uploaded to an artifactory whenever a PR gets merged. And for such commits, we can easily download the debug applications and run the UI test. All we need to do is we need the XC test run file and the debug applications for this scenario. And apart from that, if there are any check failures, and we have seen, especially in both in Android and iOS platform also, when we run test on a simulator or an emulator, there are scenarios where tests will be flaky, even though it's an intermittent scenario, it does not always fail. But because of the remote systems, or maybe because of the simulators issue, and whenever there is an Xcode version update, we have seen this happening very frequently. And whenever this happens, it's not necessary that developer has to push a new commit because it's a flaky test we can consider. So we can have an option for developers to comment, let's say smart retest on a pull request, which will actually trigger the Jenkins. And in this scenario, we don't really need to run all the checks which has already passed before. So we can have a checks in the pipeline, which will make a GitHub API call for a particular commit status. And based on that, it will only determine what checks failed and what are the dependencies. And it will only run those checks, and it will skip all other checks which passed before. This will also help us save so much time when it comes to re-triggering, or when the failed is actually because of the flakiness. So we saw like we have different types of tests. There is unit test and there is UI test, and there is a different approach we can take when we are running a unit test. Usually I've seen projects when it is run in a single emulator, single simulator, it takes certain amount of time. So if you are using a fast lane, or you can do this from the Xcode build also. So this is a code snippet which you can use. You can define the maximum number of simulators where the unit test should be run. So in this code example, I have, let's say if we are taking 3 maximum simulators, it does not mean that it will always run on 3 simulators. Xcode actually determines based on the CPU usage, whether it's a 4-core machine or it's an 8-core machine. So it will allocate the number of simulators, but the maximum number of simulators is something you can limit. And also one thing to remember is not necessary like every time we run a test on a parallel execution, it's going to improve the performance. I have seen in many cases when we run a scheme or a target unit test on multiple simulators, it actually took more time to run just because it has to boot all the simulators, and booting the simulators also takes like 10 to 15 seconds sometimes, and sometimes I've seen it takes like 1 to 2 minutes also. So I would recommend to experiment with the simulator configurations. Maybe try with 3 to be starting with, and then increase by 1. And it also goes well with how the tests are written. So it is recommended also, like I've seen some documentation online also, if the tests are written and divided across multiple classes, the save when it is run in parallel mode is evitable. But if the tests are added to the same class, and if there are, let's say, 2 class with 100 unit tests each, you won't see performance improvement when it is running in parallel mode. So this is something which I'm currently using in the pipeline, and we have seen at least 15 minutes improvement when the tests are run in parallel mode. Again, it depends on the different factors which we need to experiment with the number of parallel simulators. And apart from that, when there are check failures in the CI pipeline, not I know there is an email notification which gets triggered when there is a check failure or when there is a comment on the pull request, but not every developer will keep on monitoring the email or keep on refreshing the pull request on what is happening with the CI checks, especially with a large project like this. So it is recommended to have a comment on the pull request with details on what test failed, whether the test is owned by the respective the PR owner or it is owned by some other teams. Because if you're working with the multiple feature teams and the test is failing because of a flakiness, it is better to have the code owner details so that the PR author can reach out to the respective code owners with the reason as to why it is failing. And also having a Slack notification definitely helps because we all live in a world where we don't really use email notifications that much, or also the GitHub pull request comments. So Slack notification is something which developers usually prefers whenever there is any failure notifications on the pull request. So apart from that, with the Xcode 11 version, I think Xcode 11 or Xcode 10, Apple has changed the way the unit test or the UI test results are being generated. And the XC result is the new format, which is currently holds all the data with respect to like the test run, whether it is failing with the screenshots, if you have that in the framework, and the failure reasons and the crash details and everything. But there is a very minimal documentations on how this XC result can be passed from the command line. If you even search in the Apple documentations, you will not find any information about this. So there is a Fastlane plugin, and also there are command line tools I mentioned in this. Trainer is a Fastlane plugin which we are using in our project. So this will basically take the XC result path and it will give you an XML result output with the test run and the failure details and the crash details also. And if you want a screenshot instead of just the XML report, we can use the ChargePoint XCParse command line tool, or we have XCTest HTML command line tools also. And there is a limitation with the number of XC result which can be stored in a directory when you are running from command line or also from the Xcode. So it has a minimum of 2 XC result which can be stored in a directory. After that, if you keep on running a unit test or a UI test, Xcode automatically deletes the old XC result files. So this is something we need to keep in mind when we are designing designing a CI/CD pipeline, or when we want to retry a test in a particular folder where the report is getting stored. And with that, like we have the checks running, we know like how to run the test, to run in serial mode or in parallel mode. And there was a session talk which was presented, I think, by Mahesh on the Xcode build optimization, which talked about how we can use build with timing summary. And this is using the Xcode IDE. But designing this system in CI/CD will help us to capture the build time trend on maybe on a weekly basis and how the system is performing. And this is a command which we can use from the Xcode build to capture the build time summary from the command line. So you can push the result to a text file and store it in a Jenkins build artifact. Otherwise, there is an open source tool called XC log parser. So when we run the Xcode build to generate the build time summary, there is also an XC activity log file generated. So using this XC activity log file, we can generate an HTML using that parser. So it will show which target is taking more time and or the which class file is taking more time to compile. This will help team in identifying the root cause of the increase in build time, and also to address if there is any method which is taking more than 500 milliseconds or 500 seconds based on the expressions what we have in our project. So last but not least, after the PR is merged, we need to keep a track on how the release build app size is, because we cannot enforce this like we discussed before, because the 180 minutes time to just to generate a release build will eventually slow down the developer productivity. That's the reason after the pull request is raised, we can capture the app size depending on the most used customer for the particular project. So there's a concept called app thinning. When we are exporting with an option, we can mention what variants we want to capture. Let's say in this case, I'm passing iPhone 11 6 model version, and you can get the details of what is the app size looks like when the customer is trying to download from the app store. And also you can unzip the IPA file and capture the app size and the framework size and the different plugin size and push it into metrics and have a trend of how the app size is performing over time, because app store has a limit of 200 MB if we need to download if we are not on a Wi-Fi. And this helps us to keep an eye on how the app size is trending after the pull request is merged. And apart from that, the important telemetry which we need to capture as a part of CI/CD to measure the efficiency is how much time it takes to complete the CI check from the time commit is pushed, and also how much time it takes from the time all the CI checks got completed till the time PR is merged, and how many unit tests and UR tests are run, and what is the code coverage trend. Apart from that, we also need to keep an eye on app assistant, especially for iOS, because we have this 200 MB limit on the iOS like App Store applications. But if you are on a Wi-Fi, yeah, there is no limit. If the customer is not on Wi-Fi, there is a dialog which shows up. So it's better to keep an eye on the app size trend. And you can push the data to any of the visualization tool, like you can view it on Elasticsearch or Splunk or whatever the company recommends based on the project design. And currently we are using Elastic and Splunk in our project. This brings to the end of the talk presentation. Now the forum is open for questions, if you have any.
Yes, everyone can unmute themselves to ask questions or use the Zoom chat or the Slack channel.
Okay, I see a question. How to rerun the Flick test? Is it something that CI/CD handle automatically, or iOS devs need to do something on their side? So that is something which I have not covered, but I'll explain like what can be done. The XC result parser, which I have shown, which will convert the XC result into XML file. So the pipeline can have this configurations set up in such a way that if the test fails, we can capture the class name and the test name in the pipeline itself, and maybe retry 1 or 2 times, because like I've mentioned, there are chances when the test can be flaky also. So that is one configuration what we can have. But with the Xcode 12 point, Xcode 13, I guess there is an inbuilt feature which is coming where the Xcode itself will retry automatically, but we have not used that feature yet. That is something worth trying also. But the solution which I would recommend is handling it in the pipeline itself, capture convert the XC result into XML file, pass it and capture the class name and test name, and retry running it maybe 1 or 2 times, just to make sure that the tests are not flaky. And that is something also we are using, and definitely helps to reduce the number of retries developer have to make, or wonder like why the test is failing because we have not made any changes to the particular test or to the code base. If that answers. Yeah, the pipeline, like I mentioned, Fastlane tool supports both Android and iOS. The report format is different across Android and iOS. Like iOS has XC result and you can have an XML, but if you're using an Android, I think there is an XML file, but in a different format. But we can do the retry logics in Android also. Yes. And I would recommend doing that because I've seen tests failing because of flakiness over and over again. And it's not a good developer experience if they see tests failing, which is not because of their code change. Do the Jenkins nodes have to do clone to do a build? The zip file is only 422 megs, but even then it's such a huge effort to get the latest changes. If there are two options we can follow when we have to clone a repository on a Jenkins nodes. One is every build has to do the clone like shallow depth, and with the narrow spec we can see performance improvement. But if the configuration allows, we would definitely need to try the reference repository where there is already a copy of the clone in the master Jenkins node. So whenever there is fetch we need to do, we can just fetch only the incremental changes that happened as a part of the pull request. So in this case, the number of the data size which we'll be cloning is around like 20-30 MB. It does not have to be 420 megabytes. But reference repository comes with its own caveat that we need to maintain that on a daily basis. So maybe an overnight job which will clone the repository, like it will do a full clone one time every day, maybe at 12 a.m. in the night, and it will get the reference repositories updated. So that is one option which teams can also try if you don't want to do the clone. And also, since iOS has this derived data which needs to be generated every time when we need to build an application, even from the command line, we don't store derived data in any Artifactory. And the size of the derived data is also around like 20 GB. So because of that, we do the fresh build of the application. There are options we can try for sure. Any other questions? If there are no other questions, I'll stop sharing my screen. I'll be on this call for another 5 minutes. If that's fine with you, Evan.
Yes, yeah, we'll be here until the end of the session in case there are any other questions.
Mac notes, how to manage many devs pushing the changes. So how to make availability to large uh, resource? So again, with the Mac nodes, it depends on how much the company is ready to invest, depending on how many nodes you have for a project. Again, uh, depending on let's say 80 to 120 nodes is something which you should be aiming for. If you are a large project with 150 developers, the system requirement what we see, that should really scale well for the projects, to make sure like it's able to allocate to all the CI trigger which is happening. And apart from the CI checks, you also need to account for the nightly runs which can happen, and the nightly runs for the remaining UI tests, nightly runs for release builds. And I think the range of 80 to 120 nodes is something which is going to work quite well for projects of that size. How you choose what is the best language for scripting for Jenkins jobs? So it depends on whether the pipeline what we're going to design is only for iOS platform, or it's for Android platform, or it's going to be like Android web and iOS. So like I mentioned, Fastlane is a tool which supports only Android and iOS at the moment, and it uses Ruby language. So if the project is supposed to support only Android and iOS, I would recommend to go with Ruby. If the project is expected to support, let's say, Android, iOS, and even web also, I would recommend developing the common tooling in, let's say, JavaScript or TypeScript, and leveraging that libraries in the Ruby project. So basically, Fastlane is the recommended tool, which I would say, and also Ruby. And apart from that, you can also make use of shell script or Groovy for, let's say, in case if you are writing a Jenkins file, or if you are just using Jenkins UI for standalone configurations, there is no need of Groovy object. But just for mobile applications, I would say Fastlane and Ruby is one of the options which you can explore. I would personally prefer to write it in Python, but unfortunately, Fastlane does not support. I heard like now they started using supporting Swift also. So if you are just supporting an iOS CI/CD pipeline, I think because the entire code base is written in Swift, it's better to go with Fastlane and Swift languaging, so that even developers can also contribute in case if required. We are just 1 minute to the time. Any questions, you can always reach out to the Slack channel, which Ivan mentioned in the chat. What is the preferred breaking down steps on different max nodes is good if you're running multiple unit tests, and a single node is fine. So it usually happens on multiple nodes. It does not run on a single node. So there are two types of parallel runs which can happen. One is on a single node, but multiple simulators. But if you are running independent system, just a scheme 1 and scheme 2, which is independent of each other, Jenkins will automatically pick up what nodes to run randomly, instead of us allocating what node it has to run. So it basically, usually it will be on different nodes, and it does not really matter whether it's on same node or multiple nodes, to be honest. And since you're talking about node, something which I learned recently, just 2 days back, is when Jenkins picks up an, let's say, node XYZ to run for a job, and if it is if it is re-triggered, let's say job is re-triggered after the build is complete, it always picks up the same node if it is free. I think it was done to improve the performance of the Jenkins server and the creation of the cost of creating a new nodes every time a build is run. So that is something which, let's say, if a node is not working properly or it has issues, so the job will always pick up the same node, and you can see the build failing. Um, Unfortunately, the random picking option of node on a particular job is not currently supported. So concurrency is something where we can use in this case. So build is triggered on, let's say, multiple builds are triggered, so it can run parallelly. What will happen if it is concurrency is set to 1, as it will always pick up the same node, because once a build is complete, the node is always free. It will pick up the same node again. Yeah, from config we can change the node of the machine. But if you have multiple nodes, you can have a regular expression on what nodes the job can pick up. But even with that configuration, I mean, you have to either go and update the configuration every time you want to change the node. But still, we have these limitations that Jenkins picks up the same build, same nodes, if the node is always free. If there is any alternative to randomly pick up the node whenever a build is run, I think that is something we can try, but it comes with the cost of node creation.